Arrhenius equation gives us a lot of valuable information regarding the temperature dependence of the reaction on the temperature dependence of the rate of the reaction. But it was actually the William Lewis and one of the other scientists called Max who together gave another aspect to this, how the rate of a reaction gets affected. Now the another aspect given by these scientists was on the basis of a theory called collision theory. Now according to this theory, that we need to understand the first most important is collision frequency. Now according to this theory, this collision frequency is called Z. Now according to this theory, whenever the reactants are allowed to react, their molecules collide with each other. Now the number of collisions taking place per second per unit volume between the reactant molecules is called the collision frequency of the reaction. I am repeating again, the number of collisions taking place per second per unit volume between the reactant molecules is called, or all the collisions which are taking place per second per unit volume is called collision frequency. Now according to this theory, the rate of the reaction depends on this collision frequency. But there is another factor which is to be added to this, is the EA, also called activation energy. Now in this activation energy, what does it mean? That only those reactant molecules which are having energy equal to or more than EA will be sufficient enough to form, or will be good enough to form the product. So now only those fraction of molecules with energy equal to or more than EA will form the product. Now that fraction of molecules with energy equal to or more than EA is equal to e to the power EA over RT. So in total what we can do is, the rate can be represented as the collision frequency, the total number of collisions taking place per second per unit volume of the reaction should be multiplied by the fraction of molecules which are having energy equal to or more than EA. So that means now this much will be the amount, or this much will be the number of collisions which will be going to determine the rate of the reaction. Now according to this theory, there is one more factor which actually decides the rate of the reaction. The third factor is the orientation factor, represented by P. What is this orientation factor is? It says that according to this factor, the colliding molecule must have proper orientation so that the proper bonds can be formed, or intermediate states can be formed, and the earlier bonds are actually broken and new bonds are formed and the product is obtained. If the molecules colliding are not having proper orientation, they will just bounce back. It can be explained by this example that if hydrogen is reacted with iodine, we know it forms Hi. Now this hydrogen and iodine must approach each other like this, so that an activated complex like this is formed, in which earlier bonds breaks up into two like this, and new bonds between H and I are formed. So ultimately we get two Hi molecules. So this is the activated complex. Now if their collision is not like this in this orientation, if it is like this, nothing is going to happen. So there are three factors. The total number of collisions per second per unit volume of the reaction is called collision frequency, out of which the fraction of molecules with energy equal to or more than EA is going to decide that whether the product is formed or not. That's called EA, or activation complex factor, which I have shown you that how it can be included. And the third factor is orientation factor. That out of these two, only those with proper orientation can form the product. So in overall, if we combine all this, what we get is that the rate will be Z into e to the power minus EA RT into P out of the total collisions, collision frequency, the number of collisions per second per unit volume of the reaction, the ones with the energy sufficient enough to form the product, and with proper orientation is going to decide the rate of the reaction. Now this product of Z and P is called A, the Arrhenius constant, or we normally write it like the pre-exponential factor or frequency factor, and it is when multiplied by e to the power minus EA over RT gives us what? The rate. So this is how we can explain how the reaction takes place, and that is why what we find is the reactions with order 3 or more than 3 are very rare. The reason being that the probability of the collision of 3 reactants or more than 3 reactants colliding together to form the product becomes very rare. That is why such reactions either are very slow or are very rare. So this is how the collision theory explains the rate of the reaction and how it is being determined and what are all the factors on which it depends.